So this is a question from Evangeline. Later in the game, John is running with a velocity of 5.8 meters per second. He then accelerates to a velocity of 7.3 meters per second. He covers a distance of 17 meters while he is accelerating. First question, calculate the time taken to do this. You'll notice that I've drawn the kinematic equations down the side here, and I've also given all of the variables down here that are just from the text. You can do that by highlighting, might be an easy way for answering questions. But what I'm looking for here is one of the kinematic equations which links these four variables. So if we come back up, we're going to see that d equals vi plus vf over 2 times t matches what we have. So we rearrange that for t to find the answer. I'm not going to get into too much detail on the actual answers because it is your work to do, Evangeline. So anyway, second question. Oops, I should come back up for it. Second question, John has a mass of 67 kilograms. Show that he has gained 660 joules of kinetic energy as he speeds up. So we're talking about a gain in kinetic energy. So how would I approach question 2? We're looking for the change in kinetic energy because it's been a gain. A gain is a change. Change in kinetic energy is the final minus the initial. And you may have done this as a vector equation before, but this is not a vector equation, this is just the quantities. So the kinetic energy formula, half mv squared, and your mass is constant. You've been told that in the question, but your velocity is changing from 5.8 to 7.3 meters per second. So you can plug all those numbers and work out the change in kinetic energy and see if that matches. If it doesn't match, it may be that the question's being interpreted in a slightly different way, or is possibly poorly worded, but I don't know. We'll have a look at that. 3. A teammate passes the ball 420 grams along the ground to John. The ball reaches John with a speed of 13 meters per second, and John kicks the ball straight back at a speed of 16 meters per second. Calculate the change in velocity. 13 to 16 meters per second. However, we're starting to get into the idea of vectors here, and this is one dimensional example. We've got the ball coming along at a particular speed, initial speed, and then that's the initial, and then the final is back in the other direction. I think I got the links around the right way. I'll just double check. So reaches him with 13 and he kicks it straight back at a speed of 16. So this is actually a longer vector. Let's make it longer like that. Okay, so that final velocity is longer. It's very tempting to just say the difference is 3, but remember one is in the positive direction and one is in the negative direction, so the change is actually a bit different to that. I'm not going to give you the answer once again, you need to think about it a little bit yourself. Excuse me. Question 4. During John's kick, his foot was in contact with the ball for 0.23 seconds. I'm just going to sketch some little notes down the side here because I'm going to keep close to the question. This is more complex. This is the culmination of all of those other bits of information brought together, or at least from the previous question anyway. So the time that his foot is in contact with the ball is 0.23 seconds. Let's bring it across just a tad, and we have to calculate the size and the direction of the force on the ball. Okay, make sure you note that that's the force on the ball, not the force on John's foot. So the direction is kind of easy enough, I guess. It'll be in the opposite direction to that which the ball was originally coming in. So if that's the direction the ball was originally coming in, the force is going to be in that direction. What remains is just to work out the magnitude. We've got the mass of the ball, we've got the change in velocity from the previous question, and I'm just going to shift off to the side to finish off this. And you might, if we write the change in velocity from the previous question, whatever you calculated that to be, we've got the time, and what else do we have? The mass of the ball. We've got the mass given there, which was in grams. We need to convert it to kilograms to be consistent. But there's a few things which link force, time, change in velocity, and mass. You could use two different ways, which are essentially the same way. You could use F equals ma, and use acceleration being the change in velocity over the change in time. Or you could jump straight to your equation of impulse, the force times the change in time is equal to the change in momentum. And if you remember that change in momentum or momentum is mass times velocity or change in velocity. And that'll link you through everything. So that equation and or these equations here is enough to do it, because you've got the change in speed from the previous question. There you go. I think I gave away probably more than I should have, but that's what you have. But yeah, that's what you have. I just got interrupted by a pop-up. Hopefully that didn't affect the flow of things.